Here are the answers for the section 13-4 homework. Page 507, oral. For question number 1, we're asked to say whether or not this sequence is geometric or arithmetic or neither type. So let's look at what's happening from term to term. To be arithmetic, you have to add the same amount each time. We don't have that. To be geometric, you have to multiply by the same amount each time. From 2 to 10, it's timesing by 5. From 10 to 50, it's timesing by 5. And from 50 to 250, it's timesing by 5. So this is geometric. And the value of r is 5. Number 3, what's happening from term to term? Well, it doesn't look like it's adding or subtracting the same amount each time. So let's see if there is a common ratio. From 24 to 8, you would multiply by 1/3. From 8 to 2 2/3, you would multiply by 1/3. And 2 2/3, which is the same thing as 8/3, could be times by 1/3 to make 8/9. So this is geometric. And the value of r is 1/3. Number 5, from -3 to 6, it's adding 9. From 6 to -12, it's subtracting 18. So we can see already, just looking at the first couple terms, that it's not arithmetic. There's not a common difference. Now what about a common ratio? From -3 to +6, you would have to times by -2. From 6 to get to -12, you would times by -2. From -12 to 24, you times by -2. So this is geometric. There's a common ratio, and it is -2. For the written assignment, we're given the first term of a geometric sequence, and we're given the common ratio, and we're asked to find the first 4 terms. So write the first one down, and then start multiplying by the value of r. 1 times 3 is 3. 3 times 3 is 27. 27 times 3 is 81. There are the first 4 terms of a geometric sequence. Number 3, the first term is 3/4, and to get the next term, you multiply by the value of r. So 3/4 times 1/2 is 3/8. 3/8 times 1/2 is 3/16. Then 3/32. Next, number 7, we have a geometric sequence. The first term is 4. The common ratio is 4, and what we're asked to figure out is what would be the 4th number in the list. Well, one way to get the answer would be to write down the first one, and then to times by 4 to get the second one, and to times by 4 to get the third one, and then to times by 4 to get the 4th number, which is the one we want. So we can see the answer is 256. But if we wanted a number that was further along than the 4th one, that would take a lot of time to finally get to the term we're interested in. Let's make use of the general term formula for a geometric sequence. It is on the very bottom of page 506 of the book. And the formula is t sub n, or a lot of times we use a sub n. It means the same thing. A times r to the n minus 1. So if we want to get the 4th term figured out, you use the first term for a, that's 4, and then fill in the r, that's also 4, and then the exponent is 4 minus 1. So 4 times 4 to the 3rd power. And when you work that out, that is 256. Number 9, 5, 10, 20, we can see that the value of r is 2. We also know the value of a, the first term. We want to get the 7th one. So to find t sub 7, you use 5 for a. For r, use 2. And the exponent is 7 minus 1. So this makes 5 times 2 to the 6th power, which you can figure out on a calculator. That result is 320. Next, number 13. We're given an equation for function f, and we're told to use 1, 2, 3, 4, and 5 for our input values for n. So let's substitute those numbers in place of n and find those answers. Starting with a 1. 1 minus 1 is 0. 2 to the 0 is 1. 5 times 1 is 5. When n is 1, function f has a value of 5. Now let's fill in 2. 2 minus 1 makes 1. 2 to the 1 is 2, and 5 times 2 is 10. When n is 2, the value of the function is 10. Think of this as a sequence. The first term is 5. The second term is 10. Any predictions what the next one is? Let's fill in 3. 3 minus 1 makes 2. 2 to the 2 is 4, and 5 times 4 is 20. Can you see the common ratio yet? Moving from term to term. You're timesing by 2. This next one is going to be 40 and then 80. Now we're asked to graph this. We really only need quadrant number 1 of a grid. And this will be our n-axis. We're going to count to 5. This will be our f of n axis, and we got to get from 5 to 80. So maybe this is 10, 20, 30, 40, 50, 60, 70, 80. Now let's graph the dots. 1, 5, 2, 10, 3, 20, 4, 40, and 5, 80. We're not going to draw a curve through it, however, because for this function, our domain are just these integers for n. We're not using all real numbers for n. Probably, though, you notice the shape of this is the shape of an exponential curve from an earlier chapter. And when you look at this, this does look like an exponential function. The base is 2, and the variable is in the exponent. Number 15. Let's substitute 1 and then figure out what this makes. 1 minus 1 is 0. Negative 3 to the 0 is 1. Now fill in 2. 2 minus 1 makes 1, and negative 3 to the 1 makes negative 3. Now fill in 3. 3 minus 1 is 2, and negative 3 to the 2 is 9. Can you see the value of r? You're multiplying by negative 3. So this is negative 27, and then positive 81. Now we're asked to graph this. Again, we want to get to 5 along our n-axis, and we got to get up to 81 on this axis. So maybe this is 80, and then halfway between there is 40, and then halfway in between there would be where 20 is, and so on. So 1, 1 is going to be a dot just a little bit above the n-axis. 2, negative 3 is actually down here. 3, 9 is about right there. 4, negative 27 is down this way. And 5, 81 is up there. Again, you're not drawing a connecting curve or anything through the dots. Number 19. There are 2 geometric progressions of real numbers that have a first term of 7. So I wrote a equals 7. And a fifth term of 112. So I wrote a sub 5 equals 112. Find 2 different values for r. The reason there'll be 2 numbers is it could be positive or negative. So to figure out r, let's use our general formula for a geometric series. A sub n equals a times r to the n minus 1. And for a sub n, let's put in 112, realizing we mean the fifth term. The letter A is 7. And so for n, it's a 5. This is 112 equals 7 times r to the 4th. Now divide both sides by 7. 16 equals r to the 4th. And now we see why we're going to get 2 different answers for r. Take the 4th root of 16, but when you do an even index root, there's a positive and negative version of that. And that equals to r. So r is positive or negative 2.